Hello and welcome everyone. Welcome back to the channel. This is the binomial series, binomial expansion series video part 4. And as we had solved past paper type questions in the previous video, we are going to do the same in this video as well. We are going to start with one question which appeared in Feb-March 2024 from paper 1-2, and this is question 6 of that particular paper. If you observe, it is a 5-mark question. Just imagine the kind of working that is needed for this question is going to be a little intricate, and we just have to be cautious. That's it. It's not going to be difficult. You will also be able to experience the same. Yes? Let's read the question. The most important part is to read the question. What is said is, it is given that the coefficient of x cube in the expansion of so and so is 432. Find the value of constant a. Right? So now you are seeing that we have two brackets over here that are multiplied with each other, which means we have to first expand the one with whatever power is, and then we move on to multiplication of those two brackets to find the required power and then equate with the given coefficient, right? Okay, so from our experience in the past, what do we understand? That 2 plus ax the whole raised to 4, if we were to expand this and get the coefficient of x cube, it would be which term? The first one would be x raised to 0, second would be x raised to 1, third would be x raised to 2, fourth would be x raised to 3, and the last one would be x raised to 4. Yeah. So what I'm going to do over here is I'm going to expand or find out coefficients of only these two, not even 3, these two only. Yes. Why these two? You will understand when we multiply these two brackets and then figure out what is expected. Yeah. So let me focus on coefficient of x raised to 2 and x raised to 3. Why am I looking at coefficient of x raised to 2? Because when I multiply in the bracket something plus something x squared plus something x cubed with a linear binomial, the ax when it gets multiplied with x cube becomes x raised to 4, which is not our area of interest because we are only looking at x cube. Whereas if you multiply ax with x square, it becomes x cube, which is my area of interest, and that is the reason I need to know what is the coefficient of x square along with coefficient of x cube. Yes. Chalo, let's look at this one. So for x square, how do we work this out? 4c and the power of 2 goes in the bottom over here times 2 raised to 2 times ax raised to 2. So that gives me, what is 4c2? 4c2 is 6 times 2 square is 4, and this is a squared x squared. That makes it 24 a squared x squared. Okay, that is one thing that I need. The other thing that I need is coefficient of x cube. So this is 4c3 times 2 raised to 1 times ax raised to 3, which makes it 4c3 is 4 times 2 times a cube x cube. Okay, which is 8 a cube x cube, right? Now, as my final step for this expansion, 2 plus ax the whole raised to 4 can be written as plus 24 a square x square. I'm only going to write the terms which I am interested in. I'm going to skip the other terms that are not required for this expansion. That's it. I'm going to write only that much. Yes. What is my step 2? Step 2 is multiplication of the other bracket with this expansion. Okay, what is the other bracket? 5 minus ax. So 2 plus ax the whole raised to 4 times 5 minus ax. Okay. For this bracket, I'm going to replace it with this. So dot 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 plus 24 a square x square plus 8 a cube x cube plus dot 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 times 5 minus ax. Now, as discussed earlier, when ax gets multiplied with x square, it will turn into x cube. So my target should be 24 a square x square multiplied with minus ax. Okay, I'm not going to multiply minus ax with 8 a cube x cube because it will give me x raised to 4, which is again not my area of interest right now, because the coefficient of x cube is what is spoken about in this question. Okay, and what is the other thing? X cube I will get by multiplying 8 a cube x cube with 5 also. So I am going to consider that term as well. 8 a cube x cube times 5, and rest all is not needed. So we are going to stick to that, and this will give me minus 24 a cube x cube plus 5 8s are 40 a cube x cube plus dot dot dot. Yeah. So do you see like terms? X cube, and because of that, can you add subtract these? Yes, you can. What happens when you do that? 40 minus 24 gives you 16 a cube x cube plus dot dot dot. Okay, so that is my ultimate thing. When I say ultimate thing, that is my ultimate coefficient of x cube. But they have already told us what is the coefficient of x cube. It is 432, right? So can I say therefore 16 a cube ideally should be equal to 432, because when you expand that you should have gotten it as 432, but here we are getting it as 16 a cube, so both of them should be equal. When I divide it, what do I get? A cube, I'm going to put that in calculator. 432 divided by 16 gives me 27. So when the cube goes on the other side, it becomes cube root. So cube root of 27, guys, all of us know it is 3. That's the value for A. That fetches 5 marks for us. Perfect. Let's go through this once again in short. You expand the 2 plus ax the whole raised to 4. You take the x square and x cube coefficients and you express the expansion as something x square plus something x cube. Next thing, we multiply the linear bracket with our expansion and find the coefficient of x cube. The coefficient of x cube, as they have mentioned, should be equal to 432, and that eventually gives me the answer for A. Perfect. That gives us 5 marks, and I think that was totally worth it. Yes. Let's move on to the next one. What does the next one say? Now this question is from the year 2019, and I'm just going to go back and check which variant is this. This is okay, so that is 1 3, and we are looking at 1 1. Okay, this is not 1 1. Great. Seems to be October November paper. Okay. Not that one too. Okay, any which ways, I think we'll move on, and I'll find out the question and put it in the comment section. Can't find it right now. No worries. Let's move on. It says expand the following in ascending powers of x up to and including the term in x squared, right? So I'm focused on expanding only up to x squared. How do I do that? 1 raised to 5 plus 5c1 1 raised to 4 times 2x plus 5c2 1 raised to 3 times 2x the whole square plus dot dot dot. Why? Because I'm only interested in expansion up to x squared. 5c1 gives me 5 times 2x plus 5c2 gives me 10. I'm just gonna go check. Yes, it gives me 10 times 4x squared plus dot dot dot. That makes it 1 plus 10x plus 40x squared plus dot dot dot. That's it. That gives you 1 mark full. Yep. Moving on. Next one says 1 minus ax the whole raised to 6. You have been asked to expand this one also up to x square. Okay, so we are going to do the same thing, just that the power is raised to 6 this time. So 6c1 times 1 raised to 5, power decreases, and negative ax raised to 1 plus 6c2 times 1 raised to 4 times negative ax raised to 2 plus dot dot dot. That makes it 1 plus 6 times negative ax plus 6c2. 6c2 gives me 15. 15 times a squared x squared plus dot dot dot. That makes it 1 minus 6ax plus 15a squared x squared plus dot dot dot. That gives you 2 marks, right? Now what they are asking is, in the expansion of this multiplied with this, the coefficient of x square is minus 5. So this would have been otherwise a 6 mark question or 7 mark question, but here they have broken it up for us in parts and given us marks separately for the expansions. Yes, here they are asking find the possible values of a. We already know what is the expansion of 1 plus 2x the whole raised to 5. We already know what is the expansion of 1 minus 6ax 1 minus ax the whole raised to 6. We just need to now find the coefficient of x squared. So let us multiply. First thing is, I'll write 1 plus 2x the whole raised to 5 times 1 minus ax the whole raised to 6 with their expansions, and my expansion is 1. I'm going to copy that. 1 plus 10x plus 40x squared. The other one is 1 minus 6ax. I'm going to copy the one that I have written here above. Yes. My area of interest is coefficient of x square, which means when I multiply the constant from this one with x square, I will get an x square term. So 1 multiplied by 15a square x square. Then if I multiply this 10x with minus 6ax, I will get an x square term times minus 6ax plus lastly the x square term from here with the constant here. That makes it 40x squared times 1, and everything else plus with a dot dot, right? So now we have 15a squared x squared minus 60ax squared plus 40x squared plus dot dot dot. Yes, one good thing that they have given is that the coefficient of x square is equal to -5, which means if I take the x square common over here, I will get 15a squared minus 60a plus 40 plus dot dot dot. Yes, which means this whole thing ideally should be equal to what? -5 over here, right? So let me equate that. Makes it 15a squared minus 60a plus 40 should be equal to -5. If I take the -5 over here, this will become a quadratic in a squared, in a rather. That gives me 40 plus 5 equals 0. Which makes it 15a squared minus 60a plus 45 equals 0. Now if you observe, all the terms are divisible by 15, so I am going to divide by 15 throughout, which will make it a square minus 4a plus 3 equals 0. If you try to factorize this, you will get a minus 3 times a minus 1, which makes it a minus 3 equals 0 or a minus 1 equals 0. What do I need? I need the possible values of a. So a equals 3 or a equals 1. These are the two possible values of a. Yes, perfect. So this involved not only binomial expansion but a little bit of quadratic equation solving as well. Yes, perfect. I'm going to go on to the next one, and yes, this is the one that I really wanted to discuss, because here we're going to try and understand that how life is different when we are trying to expand a binomial when you have x's in both the terms. Okay, fine. Let's look at this question quickly. In the binomial expansion of this, the first three terms are so and so. Find the remaining three terms of the expansion. Okay, so there are going to be a total of how many terms? 1, 2, 3, and they are asking remaining 3. So there are total 6 terms. Okay, yes, obviously 5 plus 1 gives me 6. So whatever is the power, you add 1 to it, and that's the total number of terms that you will have in the expansion, right? So how do we find out the remaining terms? Let's look at what they have done, and whatever they have gotten, we have to find out everything apart from whatever they have found out, right? If we were to expand this, then we would have 2x the whole raised to 5 plus, as we know, 5c1, 2x raised to 4 times -1 by 2x plus 5c2, 2x raised to 3 times -1 by 2x raised to 2 plus 5c3, 2x raised to 2, -1 by 2x raised to 3 plus 5c4 times 2x, -1 by 2x the whole raised to 4 plus -1 by 2x the whole raised to 5, right? I will have to push this down a little bit so that we get a little bit of space above over here. Let's see what are we getting over here. 2x the whole raised to 5 makes it 2 raised to 5x raised to 5, yes, plus 5c1. I'm going to look at this 5c1, 2x raised to 4, and this, right? So 5c1 is 5 2 raised to 4 is 16 x raised to 4 times negative 1 by 2x, which means I can cancel out 1x from here, and from here I'll be left with 3 x's out there, plus I'm focusing on the next term now. See this one, 5c2 is 10 times 8x cube. Why 8x cube? Because 2 cube is 8, x cube is x cube, times 1 by 4x square. How do I get that? You are squaring this expression. I'm sorry, minus 1 by 2x the whole squared. So you square everything, numerator and denominator both. Perfect. Moving on, I'm going on to the next term. This is my next term. 5c3 should give me 10 again, times 4x squared times negative 1 by 8x cube, because 2 cube and x cube both we are looking at. Then you have 5c4, where you have 5 times 2x times 1 by 16x raised to 4 minus 1 by 2 raised to 5 and x raised to 5. 2 raised to 5 is 32, x raised to 5. Yes. Now we are going to simplify it so that we get the answer in one line. Let us look at simplification starting from here. Yes. 2 raised to 5, x raised to 5. 2 raised to 5 is 32, x raised to 5, which is also the first term that they have gotten. Now, can you cancel out something from here? For example, 2 ones are and 2 times 8. So 5 times 8 is 40. So you have minus or negative 40 x raised to 3. If you observe, there was one x that had gotten cancelled, right? Over here, in the next term, x square and x cube, you are left with 1x over here. You are left with 4 ones are, 4 twos are. So you have 20x left over here plus 20x. This is what they had already expanded. What is needed is the next 3 terms. So I'm going to now start cancelling. 4 ones are, 4 twos are, 2 ones are, 2 fives are, right? And x square and x cube, you are left with one term, 1x only in the denominator, along with the negative sign. Please don't forget the negative sign and this guy 5 over here. So negative 5 over x is what you're left with in this term. The next term that I'm looking at is this one, and let's see what gets cancelled. X, you're left with 3, 2 ones are and 2 eights are. So you're left with plus 5 over 8x cubed and minus 1 over 32x raised to 5. These are the 3 terms that they had asked us for in this one. Yes, the 3 terms. Yeah. So that's the 3 mark that you get over here. If you understand the expansion, well and good. Yeah. Cool. Moving on. Hence find the coefficient of x in the expansion of la 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 la. Ooh, what is this la 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 la? Okay, something is already that we have found out. This expansion we have already done. We just have to multiply it with this one. So what I'm going to do is I'm going to write it as 1 plus 4x squared multiplied with 2x minus 1 by 2x the whole raised to 5, as in the next step I'm going to write it as 1 plus 4x squared. I'll write the expansion, 32x raised to 5 minus 40x cubed plus 20x minus 5 over x plus 5 over 8x cube minus 1 over 32x raised to 5. Now let's do a little bit of smart work over here and let's just observe what is asked. They have asked us coefficient of x, which means after multiplying out this and this bracket, whatever is the simplification, in that simplification you need the coefficient of x. So this guy over here is a constant. If you multiply a constant with x, you will get x only, right? So I am going to multiply out what? This 1 and this 20x. That makes it 1 times 20x. Why am I not multiplying the 1 with anyone else? For example, I multiply this with this one. 1 times 32x raised to 5. This term is not a term in x. It is only, it definitely has x, but the x has a power of 5. Whereas what they have asked us is x raised to 1 only. So I'm not going to multiply the 1 with 32x raised to 5. Okay, cool. Moving on. If I multiply the 1 with any other term, all of them are never going to give me anything that is x raised to 1. Okay, which means that multiplication is the only multiplication that happens for 1 along with any term inside the bracket, right? Moving on, this multiplication with which term will give me x? So I want x in the numerator. Let's say I multiply out this with this. 4x square times 32x raised to 5. X square and x raised to 5. They are both in numerator. So their powers will get added. Eventually this will be something x raised to 7. Which is not what we require. So will I multiply 4x square with this? No. There's no need. Okay, moving on. 4x square with 40x cube. So 4x square times negative 40x cube. Okay, what am I interested in? X, the power of x. Both of them are in numerator. When you multiply, powers get added. You will have something x raised to 5. Again, this is not what I need. So will I multiply this with this? Not at all. Okay, let's say I multiply this with x. The power will become x cube. Again, that is not what I am interested in. But 4x square with this guy. Let us see what it looks like. 4x squared multiplied by negative 5 by x. Now, if I try to cancel this out, I will be left with 1, or the power of x is 1 in this one, right? So if that is the case, this is what is the multiplication that is needed. If I multiply this again with this one, x cube and x square, they will get cancelled. You will be left with x in the denominator. You don't want it in the denominator, you want it in the numerator. Furthermore, if you multiply this with this, the x square in the numerator and x raised to 5 in the denominator, you will be left with some value in the denominator, which means you will be left with 1 by x cube. Again, which is not what you intend to have. So there's no more multiplication left, which is why this is going to be our ultimate thing. Minus 20x. Ooh. Plus 20x minus 20x. That makes it 0x. So what is the coefficient of x in the expansion? It is 0. So your final answer should be coefficient of x is 0. Perfect. I hope all of this made sense, and stay tuned to watching some more videos on not only binomial expansion, but the next series that is coming up from Students' Choice is a series on quadratic equations for pure math AS levels. So stay tuned, and we are going to have another video very soon. Thank you so much for all the love and support. See you all in the next video. Bye bye.